In this video, we're going to talk about SRE, or Site Reliability Engineering, which is becoming a very popular term in the DevOps and generally the software development world. And I'm sure many of you are interested to know what it is exactly. So first we will see how SRE emerged and why was there even a need for SRE. Then we will see what SRE definition is, what system reliability means exactly, and how SRE actually works in practice, like measuring reliability with SLAs and so on. After which we will go into detail and see exactly what are the tasks and responsibilities of an SRE role. This will make it clear how the work process of an SRE team looks like and what are their daily activities. And finally, we will talk about how SRE compares to DevOps, which is a commonly discussed question nowadays. So I recommend that you watch my recent DevOps video first, where I explain DevOps in detail, because this will make it definitely easier to understand the topics in this video. So let's get started. In a traditional software development process, we have developers and operations as two separate teams, each of them with their own goal. While developers want to push out application changes as fast as possible to the end users, operations want to keep the application stable. So they are very careful about each and every change. And this causes a conflict of interest between these two roles, forcing them to work against each other instead of collaborate. And DevOps was actually introduced to help fix exactly this issue. Again, as you learned in my What is DevOps video. However, while DevOps made release process faster, these releases were not as stable as ideally wished by DevOps principles. Plus, in DevOps team, there was no dedicated role or person that actually focused full time on keeping systems reliable. And that's how the need for SRE and a site reliability engineer as a separate role emerged. Specifically, SRE was conceptualized at Google by Ben Traynor, a software engineer who was given a task to run a small team of other software engineers to do what used to be operations work. And according to his own definition, SRE is what happens when you treat operations as a software problem and stuff it with a bunch of software engineers. And at its core, SRE teams are made up of software engineers who build and implement software to improve the reliability of their systems. But this definition is, of course, too vague and high level to really understand how it's implemented in practice. So let's break it down and analyze each part of this definition step by step. So first of all, what is a system that we want to keep reliable? Or what does a system even mean in this definition? Well, the system is the servers, infrastructure, the platform, so the whole deployment environment where the application runs. Now, what exactly is reliability and why is it so important to keep our systems reliable? Imagine you work with emails daily and your email provider is down once a week, or your online banking application is down and not accessible regularly. This would be unreliable services. You can't rely that it's available when you need it. On the other hand, many popular services like Gmail, Twitter, YouTube, etc. are rarely inaccessible. So these systems are pretty reliable. But the thing is, users usually do not notice reliability of the system. It only becomes visible when something goes wrong and the services are down. Do you remember the recent outage of Facebook, Instagram, and other related services? That made huge news. What about AWS server outages that also affected other applications that were hosted on AWS? Of course, everybody noticed and knew about it when it happened. So the more popular and bigger the product or service, and the more used, the more impact it will have if the service had an outage, which means more their team should worry about its reliability. Now, what are the effects or impact of outages or system unreliability? Well, for most of the services, this is a lot of unhappy customers and lots of lost revenue. Like imagine online shop is down on a holiday or online bank is not working because of traffic overload. This means lots of lost business because people cannot order anything on that shop. So system reliability is very important for business. Okay, so we understood that systems need to be reliable. But how do we make a system reliable? Or, asked differently, what makes system unreliable? What affects its reliability? Well, the main cause of system becoming unreliable is when you make changes to your system, like change something in the infrastructure, the platform where the application is running, the application itself and its services, and so on. And this may cause a disruption and break something in the whole setup. Well, as a solution, we can say no changes allowed, or limit the amount of changes to keep systems reliable. But that really limits the business. We want to make changes and improvements to our application to make it better and increase its business value and stay competitive, etc. Because if our competitor is bringing out new features, we need to keep up. And that's the main focus of software developers, to make those changes and improvements. But on the other hand, if the application is not accessible, that's also bad for business. Because you may have awesome features, but nobody can use it because application is down. And it's the operations job to take care of that and make sure the application is accessible. This means devs want to release fast and ops want to keep stability. So traditionally, devs would make a change and ops would analyze with hundreds of checklists and mechanisms to make sure the change would not affect the system. And this whole analysis and evaluations slows down the release process. And that's been the major challenge of the traditional way of software development. And that's exactly what DevOps and SRE try to solve. So what's the specific solution of SRE here? Well, SRE tries to automate the process of analyzing and evaluating the effects the change will have on our system reliability. Automation means no checklists or discussions of operations team whether to release the change or not, or what threats and risks are involved. Instead, the evaluation is based on automated process, and this makes releasing changes fast and safe at the same time. Now, before moving on, I want to give a shout out to our sponsor, Loft. Loft is actually the first platform for platform engineers. It lets teams build a self-service Kubernetes platform in days rather than years. So how it works is that platform teams usually sit in the intersection between SRE teams and engineering teams. They build self-service systems for the engineering teams to be able to get access to cloud computing resources that usually only SREs have access to. The goal is a better developer experience and that developers can build more resilient applications and test distributed systems more realistically early on in the development process. Loft is actually also the creator of vCluster, which is an open source project for creating virtual Kubernetes clusters. vCluster is the first certified Kubernetes distribution for virtual clusters, and it allows to spin up lightweight clusters inside the namespaces of Kubernetes clusters, which is a great way for securing multi-tenancy in shared clusters. For my followers, Loft actually provides 6 months free for their paid subscription for the first 500 people. So if you want to try it out, check out my special link and use my promo code for that. And now let's continue with our video. Now, how is that automated evaluation done? The way it works is using what's called SLAs. So what is an SLA? SLA is basically how reliable a system is going to be to its end users. So how often it's going to be up and how often it's going to be down. And it's expressed in percentage. A service that works all the time, is never down, has 100% SLA. Now you may be thinking, of course any service should be 100% reliable, right? Isn't that a natural goal? Well, not really. First of all, it's very hard to achieve 100% reliability. However, there are very few things in the world that actually need 100% SLA. So for example, if your internet provider or the customer's device itself isn't 100% reliable, which is the case with most laptops, mobile phones, and so on, then your service does not need to be either. It can be available maximum at the same rate as the underlying network or device. And in those cases, a reliability of 3 nines or 4.5 nines may be enough so that users don't even notice that there is an issue. And the more closer you try to get to 100%, the more effort it is, which, as you see, is an unneeded effort because you don't need 100% SLA for most applications. Now, what is an example of an SLA? You define a service level agreement about the accessibility of your application. So for example, a 99% SLA for application accessibility would mean that the system can be down maximum 3.65 days in a year. An SLA with 5 nines or 99.999% allows an application to be inaccessible maximum 5 minutes a year. So the rest of the time it should work. And you can actually define multiple such agreements or SLAs, not just the accessibility or availability of the system, but also things like application response time or an error rate and so on. For example, if you have an application that serves 1 million requests a week with 99% SLA, you define that 990,000 of those requests will be successful. Okay, now you may be wondering who defines these SLAs. So basically, who decides how many requests must be successful out of these 1 million requests, or how much downtime is allowed for the application? Who makes these kind of decisions? Well, this decision affects the end users and their user experience. So naturally, business people are also involved in this process. So basically, business people together with the engineers, like SRE and DevOps engineers, decide together what service level agreements they want to define for their application. And based on the industry benchmarks, competition, user feedback, and so on, business people will define the desired SLAs on a higher level, and the engineers will then define them on a technical level, and also make sure to integrate them into their DevOps and SRE processes. As I said, SLA for availability defines how long the service should be available or how much downtime is allowed for that service. And that allowed downtime is also what's called an error budget in SRE. And a team can quote unquote spend that error budget on making unreliable changes. So basically that error budget says that we're allowed to have that much downtime in our system without losing business, making customers unhappy, etc. So SLA is like a barometer. You can turn it up or down based on how reliable your system needs to be. And of course, the closer to 100%, the more effort you need to put in to guarantee the reliability of your systems. Now, once the SLA is defined, the system performance can be measured against this number. If systems are more unreliable than the SLA allows, then more resources from the SRE team will be put to make the systems reliable again, because we have exceeded that allowed amount of downtime. And until the system is recovered to be within the defined SLA, fewer changes will be allowed. On the other hand, if the system is performing well beyond the defined SLA, developers in the SRE team can release more changes. So it's a simple way to regulate the release speed of developers. If we turn up the SLA, releases will slow down and vice versa. And the SRE, or the Site Reliability Engineer, is the one who creates automated processes to calculate and evaluate whether the service is within the SLA or not. So now the policy for launching is not the endless checklist that operations use to decide whether to launch or not. Instead, an SRE helps design processes that can automatically evaluate an SLA. Now, of course, to measure the performance of our systems and whether services are within the SLA, we need proper monitoring of our systems. So as another big part of SRE tasks and responsibilities is to configure proper monitoring and logging of the systems to get visibility of what's going on inside. Now, we said that for most applications, SLA is not 100%. which means we accept that it won't work 100% of the time. So at some point, we will have an outage. Now the question is, what do we do when an outage happens? Or how do we prepare for it? And that's where another big part of SRE tasks and responsibilities comes in. The first one is monitoring and alerting, which I already mentioned. So in addition to giving you a visibility to measure your system's performance, but more importantly, it helps you detect any indications for issues before they happen or very early when they happen, and then alert the teams about it. Now, another important part of this whole configuration is that when the issue is alerted, and ideally the right person in the team gets the message, the alert message should contain all the needed information to identify and fix the issue fast. So instead of something is wrong in the cluster, a more detailed message like service A in cluster B is throwing 500 error, for example. So we know exactly which service is having a problem, in which cluster, and what that problem exactly is. So more detailed the alert message, the better. In many cases, SREs will develop their own custom services to achieve this proper monitoring, alerting, and logging configuration for their systems. Another thing that SREs do is on-call support. So basically, when things go wrong and users need real-time support, somebody is responsible for doing that, and that is on-call support team. And putting SREs on this support team helps them really see and understand what issues to expect, how the support deals with the issues, and what improvements can be made to make the support process more efficient, such as do alert messages and logs have enough information to quickly identify the issue and the cause, were issues identified too late, etc. So overall, the main goal of SRE is to make sure the scope of outage is small when it happens, which means the outage doesn't last long and is fixed very quickly, and less people and few services are affected by that outage. Now, there is one challenge about detecting the issues that you may not think about immediately, and one reason why it's important to prevent issues or identify them as early as possible. In practice, when the system is configured properly, you usually have multiple mechanisms for high availability, reliability, self-healing, etc. So one small bug in such systems will not cause an outage because you have protection mechanisms for that. And this means that multiple things must go wrong before system becomes unreliable and before you actually have an outage. So when an outage does happen, you don't have one thing that you need to fix, but rather multiple issues or a chain of issues on multiple levels that you need to fix. So fixing that array of issues is more complicated and takes more time before the system has recovered and is back available for users. So these additional protection mechanisms do protect the system and make it more reliable, but they also make it more challenging to detect the issues early. So in this case, it's even more important to configure a proper monitoring, logging, and alerting configuration to overcome this challenge. Now, fixing an issue or an outage is not the end of the SRE team's work. We want to use that outage as a chance for lessons learned, and of course, avoid that this happens in the future. So as a principle of SRE team is to do what's called post-mortem, which is Latin for after death. So in SRE terms, after issue or after outage analysis. And this includes a thorough analysis, meaning taking time to really go deeper and understand the issues. What caused this outage? Go through the whole chain of who did what, who fixed what, how you were able to deal with it, etc. But of course, during this analysis, it's super important to stay blameless, which is one of the major points of this post-mortem analysis, in order to encourage people to admit and learn from their and other people's mistakes. And finally, it's important to document everything for future reference. Now, you may be thinking, how much more should software developers learn? They already have to know all these software development technologies. Now they also have to take over the operations tasks and learn all these operations tools. And that's why we have SRE as its own role. So a dedicated person whose full-time responsibility is to work on keeping systems reliable. So in many projects, along with developers, you have SRE teams, which are the new ops team. Basically a team that does the operations, where both teams work for the same goal of keeping the systems within the defined SLAs. So the SRE team maintains and takes care of the automated delivery, operations, and all sorts of automation that will help developers release their changes safely and fast. However, it's also common to have one team of SREs and software developers where SREs also do the software development job. And this means that SRE engineers must know software development as well, unlike DevOps engineers. But in both cases, as you see, we started off with a traditional way of software development with separate dev and ops with opposing incentives, and with SRE, we gave devs and ops the same incentives and put them on the same side. And finally, one of the majorly discussed questions in this area is what is the difference between SRE and DevOps engineer, or generally between these two concepts. If you already watched my What is DevOps video, you know that there are two definitions of DevOps. The original definition, which is more high level and more broad, and doesn't specify how exactly DevOps should be implemented, and a more practical one, which evolved over time with its own DevOps engineer role. So when we compare DevOps with SRE, it's important to know which definition of DevOps we're using for this comparison. So with the first broader definition of DevOps, DevOps is a more high-level concept that defines what needs to be done to achieve the automated, streamlined release process, while SRE is more specific about how to exactly implement this process and how to implement DevOps principles. So many people would say that SRE is a specific implementation of the DevOps concepts. But as you saw in my What is DevOps video, DevOps itself also became more practical with its own role and specific technologies and ways to implement it. So what's the comparison here? Well, in many companies, DevOps implementation, this practical DevOps implementation, became more focused and concentrated on the speed of delivery for the application changes. And of course, even though it's part of the DevOps principles to not only release fast, but release quality code, many DevOps teams in practice, again, seemed to optimize more for the speed than reliability. So as a great complementary part of DevOps, SRE emerged with the same principles and goals in mind, which is release quality code fast, but as the name suggests, more focused on reliability and keeping systems stable while allowing for fast changes. So SRE is its own role with its own set of tools for making systems reliable. So these two were kind of parallel developments and are now often seen as two sides of the same coin. And it's not uncommon for teams to have both DevOps engineer and SRE helping implement the DevOps principles. Now, I hope you learned a lot in this video and that I was able to answer all of your questions about SRE. Now, if you have worked or are currently working as an SRE, please share your experience in the comments because I'm sure it will be very interesting for others. One thing I also want to mention is to be sure to check out our course roadmap for this year, because based on your feedback, we have planned to create a few courses. We may not be able to create all of them this year because we try to create the courses with a super high quality content instead of creating as many as possible, so the process takes longer. So sign up to get notified when we release the courses. And with that, thank you for watching and see you in the next video.